Lesson 97 are two-step problems. These are kind of fun. I think you guys will enjoy them. Okay, so looking at your notes, it says if you have this equation, 2x plus 4 equals 6, what is the value of 3x minus 7? Okay, so when you look at these, which of these two equations can you solve? Can you solve this yet? You can't, because it's not set equal to anything. But this one here you can solve because we have a full equation. This here is an expression. And at this point, we cannot solve it. But once we figure out what x is, we can use that value to solve this expression. So if you'll recall, and I do hope it hasn't been such a long break that you can't recall this, but when we have an equation like this, 2x plus 4 equals 6, the first thing we want to get rid of is the constant. All right, the constant in this equation is the 4. So the only way to get rid of the 4 is to do the opposite of what's happening. Right now 4 is being added to the left side. We want to do the opposite to both sides. So we will subtract 4 from both sides. Okay, and we're left with, 2x equals 2. 6 minus 4 is 2. Now we can divide both sides by 2 because right now we have multiplication going on here, 2 times x. So in order to undo that, we need to divide. So we're dividing both sides by 2. And that gives us just x on the left equals 1 on the right. But we're not finished because our whole point is to use that value in order to solve this expression. So I'm going to change my colors. I'll make my x green, and I'll have the rest of my equation in yellow. So 3 times 1 minus 7 equals, whoops, I forgot about changing my color, didn't I? So 3 times 1 minus 7 equals, well, that equals 3 minus 7, which equals, remember, that's the same as 3 plus negative 7. All right, so that gives us a negative 4. So negative 4 is our actual answer for that problem. Let's do another one of those. Let's actually jump down to the bottom. So it says if 1/5 x equals 3/10. Then what is the value of 5x plus 2? Okay, this is our expression. 5x plus 2 is our expression. We can't solve that until we know what x is. So once again, we want to do the opposite of what's happening. Right now, 1/5 is being multiplied by x. In order to solve this, we have to get that 1/5 to become 1. So the opposite of multiplication is division, but when you divide with fractions, you're really multiplying by the reciprocal. So we are going to multiply both sides by the reciprocal of 1/5, which is 5. And it makes sense because 5 over 1 times 1 over 5 is 5 over 5, or 1. And that way we are just left with x on the left equaling, here we can cross cancel, 10 becomes 2, 5 becomes 1, so we end up that x equals 3 over 2, or 1.5. But because we are going to enter this into we're going to enter 3 over 2 into this equation. It helps to keep it as an improper fraction at this point. So I'm going to make my equation blue, except for my x. 5 times 3 over 2 plus 2 equals, and then I just multiply 15 over 2 plus 2. At this point, there's 2 different ways we can solve it. We can change this improper fraction to a mixed number and add, or we can change 2 to have a denominator of 2. I'm going to do it that way, just for kicks. So that gives us 15 over 2 plus 4 over 2, which is 19 over 2. And at this point, I am going to change it to a mixed number. So 19 divided by 2 is 9 and 1/2. Let's solve it the other way. 15 over 2 plus 2, I'm going to rewrite the equation. 15 over 2 plus 2 is equal to 7.5 plus 2. Here we're just going to add the whole numbers, and we get 9 and 1/2. Okay, so we get the same answer either way. I would like for you guys to work on the rest of those practice problems by yourself, and I'll answer any questions you might have in our Zoom meeting. Lesson 8 is about angles. So adjacent angles, complementary and supplementary angles, as well as measuring angles. So complementary angles, you'll see I have it written rather oddly. And the reason I do is that complementary angles add up to 90 degrees. So for example, if you have something like this, and you know this angle is 90 degrees, then let's say you had something like this, and you knew that this angle was 30 degrees, and you knew that, I'm going to call this angle A, angle B. So let's say they told you angle A and angle B are complementary. Okay, then you would be able to figure out what angle A was by saying, well, they're complementary, which means they add up to 90 degrees, and 90 minus 30 equals 60. So angle A is 60 degrees. This is how you will use these things most often. Okay, this is another thing that we need to review. In your notes, I've got this diagram, and I'm going to draw it here. Probably not terrifically, but hey. So you have several points. I'll make my points in red so they're easy to see. This is M. The vertex is A. It's where the two rays come together. Here's X. Here's Y. And then we have another ray drawn out from there. And it has points B and C. Okay. So here we have coming together ray AX, or you could have said ray AY, ray AM, ray AC. Okay, all of those are represented. You could have also said ray AB. So what angles do we have? We can't just say, well, we have angle A, because there's more than one angle represented here. So what we need to do is name our angles. We can name them as angle, I'm going to erase that angle A so that's not confusing. We can say we have angle MAX or MAY. We have angle MAB. We have angle BAX. Okay, so the vertex always has to be in the middle when you're naming angles. The other thing to note here is that angle MAX, angle MAB and angle BAX are adjacent. Angles. What adjacent angles do is they share a common side. So they're both sharing this side. All right, it says adjacent angles share the same vertex and one side. Okay, so that's important too, that they share the same vertex. Because look at the examples to the right of that statement. The question is, does that first angle represent adjacent angles? You have a ray going up like this, and then this is point A. This is point C. This is angle X, and this is angle Y. And there's a point B up here. And the question is, are angle X and angle Y, whoa, that's not a Y, this is a Y, adjacent? And the answer is no, because they do not share the same vertex. And how about the next one? What are your adjacent angles? You would say that angle EDG is adjacent to angle GDF. Okay. You are to complete the practice problems from pages 305 to 306 and list your answers in that table. If there's any questions that you don't understand, then we can go over them. It's about exponents and signed numbers. I know we've already done some of these, but they're just going to get trickier and trickier as you go, so you've got to pay attention to parentheses. So, this is how you should be reading these problems. The opposite of 4 squared minus negative 3 squared minus 3 to the third power. All right, because the only negative 3 that is being, the only negative sign that has an exponent being used on it is the negative 3. You have to have the parentheses in order for the sign to go with the number when you deal with the exponent. So just for clarification, this is the opposite of 4 squared. Okay, the 4 is being squared and then being made negative. This is the opposite of 3 cubed. All right, this is the opposite of negative 3 squared. So because of the parentheses, the negative sign here gets squared with the 3. So then we would write our next step and just work out our exponents. The opposite of 16 minus negative 3 times negative 3 is positive 9, so minus 9 minus 3 to the third power is 27. Okay, so now all of our numbers are negative, so we know that we will add them all together. So we could just say that negative 16 minus 9 equals negative 25 minus 27. And then we can add those together, and we know our answer is going to be negative. Well, 5 plus 7 is 12. Carry the 1. 2 plus 2 is 4, plus 1 is 5. So our answer is negative 52. Let's look at the next one. And I would love for you guys to work these out. Pause the video, work them out, and then come back and see if you got the same answer as me. So here, negative 3 is being raised to the third power. So the negative sign as well. So it's negative 3 times negative 3, which is 9, times negative 3, which is negative 27. Minus negative 2 cubed is negative 2 times negative 2, which is positive 4, times negative 2 is negative 8. Minus 2 squared is 4. Okay, that negative sign is not being squared in that instance. So here we have a double negative, which means it becomes a positive. So now we can say negative 27 plus 8, we have to subtract. And so we will get negative 19 minus 4. These are both negative, so we're going to add. So our final answer is negative 23. Okay, stop the video and do the next one. All right, we have the opposite of negative 2 to the third power. So we're just going to write the negative out front. Negative 2 to the third power is negative 8. That double negative we can cross now if we want. Minus, and then negative 2 squared is a positive 4. So we're going to say 8 minus 4, which equals 4. These aren't too bad when you get to doing them. And our last problem is the opposite of 2 squared. So that equals the opposite of 4 minus negative 2 squared, which is 4, minus negative 2 to the third power, which we said before is negative 8. I'm going to use a contrasting color to cross our double positive. So now we get negative 8 plus 8, which equals 0. Our last section today, lesson 100, can you believe we're on lesson 100 already, is about ratios. They're advanced ratio problems. So remember what ratios are. They're comparisons of two numbers. And we use when we set them up as proportions, the cross products are equal. So, for example, it says the ratio of nuts to bolts was 11 to 2. So we have to remember, it's probably good to write out to the side that we are comparing nuts to bolts. Okay. The ratio is 11 to 2. So if there were 260 nuts and bolts in the pile, okay, so that's our total. So let's actually make a ratio box here. We have our nuts, we have our bolts, and we have our total. If our ratio is 11, so this is ratio, this is actual. So if our ratio is 11 to 2, then our total is 13. And we needed to write that because it gives us our total, which is 260. Okay? And what we're looking for is how many bolts there were. So that's our x. I'm going to put a contrasting color for that. And we aren't curious about the nuts. We just want to know the bolts. So now we can set up our proportion. So 2 over 13 equals x over 260. We can either use cross products or we can see these as equivalent fractions. I'm going to use cross products because this is pre-algebra. So we're going to cross multiply here. So 13 times x equals 2 times 260. Well, 2 times 0 is 0. 2 times 6 is 12. Carry the 1. 2 times 2 is 4, plus 1 is 5. Now we can get x by itself by dividing both sides by 13. And we find that x equals 40, because 4 times 13 is 52. All right, are we done? Not quite. We need to write that our units are bolts. We have 40 bolts. Let's do another one of those. I would like for you to try to work it out on your own. Pause the video, try to work it out on your own, and then come back. So Farmer Bob wanted to plant wheat and corn in the ratio of 7 acres to 9 acres. Let's make our ratio box. So we have a ratio, we have our actual. And over here, we are going to have wheat. I'll just use W. Corn, and total. So his ratio is 7 wheat for every 9 corns, and our total makes 16. That's just the sum of 9 and 7. And in total, he has 640 acres. So the question is, how many should be planted with wheat? So this is the one we care about. This one is not needed, but we could figure it out if we wanted to. All right, so let's write our proportion. 7 over 16 equals x over 640. We're just basically pulling these out and bringing them over. So let's solve this algebraically by cross multiplying, because proportions are true if cross products are equal. So 16 times x equals, well, 7 times 0 is 0. 7 times 4 is 28. Carry the 2. 7 times 6 is 42, plus 2 is 44. Didn't quite leave myself enough room, but it worked out okay. We need to divide both sides now by 16 in order to get x by itself. So x equals, do the division. Let's do the division out to the side. 448 divided by 16. I know it's 4,000, but how many times does 16 go into 44? Well, at least twice, because 2 times 16 is 32. When we subtract, we get 12. So we did go high enough. Bring down the 8. How many times does 16 go into 128? Well, I see 32 here, and I think, well, 4 times 32 is 128. So that tells me that 16 goes into 128 8 times. Let's see if I'm right. 8 times 6 is 48. Carry the 4. 8 times 1 is 8, plus 4 is 12. There go. We get 0. We bring down the other 0. And we find out that x equals 280. Then we have to think, what are we talking about? We are talking about acres of wheat. Okay. Do those last 2 problems on your own, and definitely start off with a ratio box and see how you do.